Okay, let's go for the next experiment. The experiment is gonna be ballistic pendulum. So in this case, we have an object, a pendulum, but we're supposed to hit it with a bullet, right? And we can move some height all together with the bullet, right? And let's try to find the height. Using that height, let's calculate the initial velocity. Okay, let's do it. From the beginning, let's try to find the initial velocity of the bullet. To do that, we have a spring gun, right? This is gonna be the spring gun, right? I just bought it, right? At the store. It's a toy, right, for kids. Okay. Then let's find the velocity at which the bullets are being sent, right? To do that, let's use projectile motion, right? So from projectile motion, we know that if we have this height and we have the impact of the projectiles right here, right? Using this equation from kinematics equations, right? We can find, right, the initial velocity. Okay, now let's do it. So let's try to, again, make some projection right here and try to find the distance from this position, right? The position of the bullet at the beginning to the impact at the end, right? And for now, let's see that's correct, right? Just using this data, 30 centimeters, right? And this height from here to here is about 80 centimeters. The angle that we are using is 0 degrees. Okay, now from this equation, which is provided in kinematics, right? Let's solve for the initial velocity, and let's call that velocity the theoretical velocity. This velocity is used, right, in the ballistic pendulum, right, to find height, correct? Okay, let's do it. One more time, we have this data. Remember, we have the equation. In this equation, delta y, right, is the displacement from the initial position to the final position in the y direction. So it goes down, so we know height, right? But because displacement is a vector, it has directions, and they're gonna be negative h. Okay, right here, please plug negative h and solve for velocity, right? Please show formulas and values and the answer at the end. Okay, once we know the initial velocity, let's use that amount to the second part. The second part is actually the ballistic pendulum. Okay, let's do it. So at the beginning, we have this pendulum with M2. Let's label the mass of the bullets M1, right? They are provided already, right? M1 is 5 grams, and M2, right, is gonna be 8 grams. So M1, 5, and 8 grams. Okay, perfect. Now, what's happening in this case? Well, we have the initial velocity for M1, the bullet, right? Hit M2, the pendulum, right? They stick together and moves as a single piece, correct? Okay, now using conservation of linear momentum, right, it's found that the initial momentum before collision, right, is equals to final momentum after collision. Okay, great. So that equation gives us that m1, right, or mass 1 times the initial velocity, right, equals to the total mass times final velocity. Okay, this final velocity is right here, the second part. So we have a collision, we have the bullet, right, hit, right, the target right here, the pendulum, and then both together moves, right, a single piece to some height. Okay, great. Now we have second part right here, conservation of energy. So at the beginning we have kinetic energy is converted into potential. Great. Okay. Well, we are right here, right? So conservation of energy, we have kinetic. In this case, M, right? Big M is the total mass, right? M1 plus M2, correct? Perfect. That's gonna be 1/2 M. Final velocity square is equals to potential energy, mgh. Great. Now, from here, right, let's solve for final velocity because we need to use it in this equation, right? When we solve it, we get that 1/2 m1 v initial divided by the total mass square is equals to, right, mg, because these m's are cancelled in these equations. Okay, now from here, please solve for the initial, right, or initial velocity, correct? And let's label this as the experimental one, right? Because we need to compare that to the theoretical one. Okay, correct. So please show the formula from here, right, from this equation. Solve for initial velocity, right? Please also show the values and the answer. Okay, great. Now, taking this into account, let's compare our percent error, right? Compare these two velocities, the theoretical one, right, and the experimental one. Okay, you know that the formula is gonna be absolute value of initial velocity from the theory minus initial velocity from the experiment divided by the initial velocity from the theory, right, times 100%. Okay, so this is again the theory for this experiment. I'm gonna show you the data that we're supposed to collect. Also, you are supposed to find this h. Everything's provided, as you can see. We're gonna do the measurements right here, right, for height, for x, and then you have to do the measurement for this new height right here, correct? To be used in the formula right here. And then do the calculations and compare this to initial velocities. We expect, right, a percent error right below 10% to have an acceptable experiment. Okay, so I'm gonna do next, right, the demo for this experiment. Okay, see you in a moment. Okay, let's go to the second part, which is the demo for this experiment. Again, we have to use this spring gang, right? It's a toy. Okay, we're supposed to find x, right? X, the distance is again about 80 centimeters. Let me show you how we found, right, this distance. Okay, it's a projectile motion that we did before in the class, right? Okay, let's do it. So to do that, we need a carbon paper, right, and a clean, right, piece of paper. Okay, let's do it in this way. Let's try to mark the impact, right, the impact, correct, of the projectiles right here on this piece of paper. Okay, great. Now let's fix these two pieces of paper, right? We have the bullet, which is a marble right here. Okay, now let's do several trials. Let's say 2 or 3, right? Let's do it all the time from the same position, right? The same position. Okay, let's try the first one. Okay, imagine it's the first one. Okay, well, I missed the target. Okay, one more time. One more time. Let's try to hit the target. Okay, hopefully it's gonna be better this one. Great. Okay. Okay, the first impact. Okay, let's try another one. Let's load right again. Okay, the first one. Okay, the second one. Perfect. Let's see one more just to see the impact. Okay, great. I can't believe it. Okay, the last one. Okay, now let's see what happens on this piece of paper. Okay, let's find the target right here, the impact. Okay, let me see. Well, we found these two very close, right, as you can see. Just be careful, don't move, right? Oops. This piece of paper, let me mark it for you. Okay, I need a pencil. I found one right here. Okay. These are the impacts right here. So it's one. Let's take only these two for simplicity, right? Those two impacts. Now let's try to measure the distance, right, from that position, right, to the initial one. Okay, let's do it. Imagine. Let's take the average. Okay, let's see to let's say I need another tape. Okay, let me do it. Okay, right here. So I need a helper, right? But that's fine. Okay, from here to, let me see, to here, right, is 160. Okay, 160 is right here. I can't believe it. From here to here is, let's see, 50 what, 57. 160 and 57. What should be? Okay, let's do it. 150 and 57, right? 150 and 57. Okay, what do we have? Well, actually 57, 67. Okay, look, this one was a little bit different. Okay, I practiced before and I got something like that. Let's see with this one. Maybe the spring is become a little less weak. Okay, so let's take this one. Okay, so gonna be what? About 117. Okay, 120. Okay, 120 for this one. Remember it's approximations. Okay, because I don't have a good measurement. So for this one, gonna be 120. Okay, let's use 120 for the moment. Okay, 120 centimeters is gonna be X. Okay, now let's go to find height. Okay, again with this session, well done. Yes, done. I can believe it. See, this is one more time, right? Okay, we are right here. Correct, perfect. We have again the ruler right here. Okay, perfect. Now we have room. Yes, we did it. I can't believe it. Now let's adjust the level, right? Okay, okay, it's level now. Great. Oops, let's make it closer for you. Okay, let's where is the target? Where's the bullet? The bullet's inside. One more time. Okay, Harry. Okay, the bullet's coming. Oops, 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 oops. Be careful with this. This is the more critical part. Okay, let's load the spring gun, right? One more time. Let's connect these two, right, to make sure they're getting together. Okay, let's try one more time. Yes. Okay, let's see if you can see it this time. If no, okay, one more time. The last one. Okay, the last one for you right there. Okay, one more time. Oops. Okay, let's load the spring gun, right? Okay, one more time. Oh my god, I thought it was easier, but look. Okay, we have to adjust everything. Okay, okay, let me see. It's ready. Okay, it's ready. Okay, let's do it. Let's do it one more time. Oops. Oh, it hits right the board, right? Okay, one more time. One more time. Don't worry, we still have time. Okay, let's load the target, the gun, right? Okay, let's see, it's ready. Let me see, maybe need to turn around a little bit. Okay, it's ready right here. Okay, okay, one more time. One more time. Let's do it this way. Okay, we need room. Okay, let's do it. Okay, hopefully we have enough, right? Centimeters enough. Look, this is 14. You can go through this one right here, right, and project more or less the height. Okay, okay, and with this we finish this experiment. We expect, right, to get very right answers, correct? Also, by the way, we need to double check, right, the masses, right, the masses that we are using today, right? Okay, let's go for finding the masses, right? This is the mass of the total mass right here. As you can see, this equals to 13, right? 13 grams. Okay, when they're together, now let's remove the marble, and now we have only M2, right? M2 is about, right, it's about what? It's about A, right?